Okay, hello dear friends. This is the fourth time I'm trying to make this video. So this one first, it's a geometry problem, and what we are doing is about polygon diagonal lines. So let me start with a brief introduction of all these terminologies. So polygon, 多边形 poly means many, gon means side or angle. As long as it's more than 3 sides, it is called polygon, many sides. Many sides. And polygons are connected by line segments. And the extremity of the line segment is just the connecting point of another line segment. And all these straight line segments connect together makes polygon. If there is a curve, it's not polygon. And the polygon can be convex, which is all going outside. In Chinese, we have this word, 凸角. And there is another shape of polygon. It could be quite complicated. This is also polygon because it's all straight line and it connected at the extremity of the line segment. So this kind of shape is concave polygon. We are not talking about this one for this particular problem. We are trying, maybe the theory is the same, the number is the same, but I have not yet tried that one, so we are not talking about that. And connecting these, the line segment which are at the side of the polygon, they are called sides. And the extremity connecting point of the two line segments, they are called vertices. And you connect the line, one vertex with another vertex, but not as a side. Here, this is called diagonal. Same here, this is also diagonal. Here is diagonal, here is diagonal, here is diagonal, but this is not diagonal. This is not diagonal. Okay, so I think I have introduced all the terminology which is usable for this exercise. What we are trying to figure out is the diagonal line, number of diagonal lines, and in connection with the side of the polygon. So we are trying to figure out if there is a pattern that we can follow. Now let's do it. So first we have sides, the number of sides, and number of diagonals. This is our recording sheet, okay? Here we have this exercise paper, triangle A, B, C. There is no diagonal line. So when we have 3 sides, there is 0 diagonal line because we do not have an extra point on it. But if we have A, B, C, D, quadrilateral or trigon. 1, 2. There are 2 diagonal lines. 4 sides, we have 2 diagonal lines. Now we see 5 sides pentagon. A, B, C, D, E. 1, 2, from B, 3, 4, 5. 5. D, it's all here. So we have 5 diagonal lines. When we have 5 sides, we have 5 diagonal lines. Now let's see 6. 1, 2, 3, 4, 5, 6. A, B, C, D, E, F, R, 4, 6. So 1, 2, 3, 4, 5, 6, 7. 等一下，宝贝儿。8, 9. We have 9 diagonal. We have 9 diagonal lines. 现在要做吗？
那我问主有 graph paper。
graph paper 有。哎，我刚才在溜溜那个桌子上，在溜溜桌子上。Okay, so when we have 6 sides, we have 9 diagonal lines. Now we do 7. 7, it becomes complicated, right? And it's better we follow a particular pattern or make it a little bit better for us to draw. So I will draw a big circle. How about that? And make evenly divide into 7 points. 1, 2, 3, 4, 5, 6, 7. A, B, C, D, E, F, G. 1, 2, 3, 4, 5, 6, 7. So we connect, make the shape. So this is the shape. Now we will draw the diagonal line. Okay? Starting from A, E, R, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, 14. Not more, not less. 14. 14. 7. Now we draw 8. 3, 4, 5. It starts to be interesting if you see it. 2, 3, 5减12等于3 9减5等于4 14减9等于5 And then I say, how about 8? Then there was one student guessing. It must be adding 6, so make it 20. Now let's prove if it is right. We draw big line. Okay, we draw a big circle. And we divide it into 8 points. 8 is even number, so you can make it just bisect. Okay, I will use pen to do it, to make it 1, 2, 3, 4, 5. Okay, we call it A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8, right? So starting from A, we do diagonal line. So AH is not good because it's connected. We have to jump through this its side. E, R, 3, 4, 5, B, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it is 20. And it is proved this is the right number. So let's guess if there is 9 sides and you will add up 7, it makes 27. I will not continue to do it, but we will try to figure out theoretically. So here we have a diagonal. No. We have a polygon. This is not pretty. Let's do a pretty one, okay? I'm sorry. That paper I will use, don't worry. I will use it for other use. Okay. 1, 2, 3, 4, 5. No, let's do 6. 1, 2, 3, 4, 5, 6. Okay. A, B, C, D, E, F. So this time we will try to figure out theoretically, and I will make the shape easier for you to see. 1, 2, 3. So let's start from A. A will make connection with how many points? With F, no, it's not right. With E is okay. With D is okay. With C is okay. So there are 1, 2, 3, 4, 5, 6. 6 points, but 3 points is not used. It can get connection with anything minus 3 points. With all the points, with all the vertices, except 3 points, 3 vertices. One vertex is itself. It cannot connect with itself. It's not like our human being. We connect with ourselves. But when we do diagonal line, we are connecting to another vertex. We are not connecting with ourselves, okay? We have to be selfish. This is mathematics. Okay, and you cannot connect with your closest neighbor. This one is not. It's not diagonal line. You have to reach out. No personal feeling. You have to reach out, not to your close neighborhood, not close to your family. You have to reach out. So 1, 2, 3, 3 points is not used. The rest of the points will be connected. So if we have n points, n 拱 多边形 poly, this poly means n, this poly is with a number of n, so we have n minus 3s for these points to connect. And how many points can make this action? 1, 2, 3, 4, 5, 6. 6. So times n. Whichever way you do it, you can do n times n minus 3 or n minus 3 times n, because there is associative the property, associative property of commutative property of multiplication. So you can do n times n minus 3 or n minus 3 times n. Okay, so here is this, and you can see A can connect to these points, and B connect, but A connect, B connect. How do I do it? So let's do A can connect 1, 2, 3 points, right? B can connect 1, 2, 3 points. Okay. And C can connect 1, 2, 3 points. D can connect 1. Oh, we see it's repeating. Okay. Do I make it more complicated than it needs to be? I am sorry if so. 到点了吗？1、2、3、4、5、6. Now we do it again, just to make sure we can see clearly. A, B, C, D, E, F. So the truth is that A can connect to 1, 2, 3. B can connect to 1, 2, 3. C can connect to 1, 2, 3. D can connect to 1, 2, 3. E can connect to 1, 2, 3. F can connect to 1, 2, 3. What did you see? So every connection have two lines, because FD equal DF, EB equal FB, CE EC, AD DB, BF FB. So everything repeated 2 times. Repeat it one more time. Repeat it 2 times. What do I say? Anything has original 1 time and repeating 1 time. So everything is 2 times, right? So we have this, and we need to divide it by 2. Now, with such formula, it makes our calculation so much easier. So let's see, let's prove all what we have trying to figure out. Okay, so with 3 lines, with 3 sides, n equals 3, 3 sides, number of sides, and number of diagonal. 3 sides, 3 times 3 minus 3 times divided by 2. Anything times 0 equals 0. Right. Right. One time, a glorious ticker. 4, 3 times, I don't know, 4 times 4 minus 3 divided by 2 equals 1. 4 divided by 2, 4除以2等于2. So with 4, we get to write 5 5乘以5减2除以2 5减3除以2等于5. We are right. 6乘以6减3除以2等于3 6 18除以2等于9. We are right. Gosh, isn't it good to figure out a pattern? 7乘以7减3除以2等于这个是4 4除以2等于2 2 7 14. Yes, we are right. 8, okay? You can just continue to do it. 8乘以8减4 8减3 My God, what I'm doing here? 8乘以8减3除以2等于8除以2等于4 4乘以5等于4 5 20. We are right. 9乘以9减3除以2等于9减3等于多少？9减3等于6 6除以2等于3 3 9 27 27. We are right. You can keep on doing it because we know the pattern. So in the class, I said, students, would you please to try to figure out how many diagonal line we have? If we have 15 vertices. So let's just do, if we have 15 sides, 15 times 15 minus 3 divided by 2 equal, 这个是12 12乘以12除以2等于6 15乘以6等于90. Okay, easy peasy lemon squeezy. Okay, I hope this is okay with you. Isn't it fun? I figure out the pattern. I remember one time one of our viewer friend give me this reasoning, and I forgot it. And now I think I know from the reasoning, deep down, understand the reasoning. Itself doesn't work. Its neighbor doesn't work, and connecting the rest, it's quite interesting. Yeah, I will not forget it. Bye bye, friends. I love you. I really do.